Welcome to this video where I will talk about the solutions of the third exercise of our first assignment in the course Competition Policy and Strategy. This third exercise is on monopoly again. In this exercise we are first asked to assume a demand function which is written in general terms, so it reads Q of P, so quantity of as a function of price, equals to A minus P for some homogeneous good. We are then asked to assume that there will be a monopolist in the market with constant marginal costs denoted as lower C. In the first exercise, or first task rather, we are asked to determine the monopoly price PM as a function of these parameters. Now, this is something that is this exercise is of course very similar to the second exercise, to the previous exercise we were just discussing in the previous video, Monopoly 1. So I will try to go over this a little bit quicker, and in case I'm missing anything or anything is still unclear, I would refer you to the first Monopoly exercise. So, in order to find the market equilibrium or the monopolist's equilibrium price and quantity, we again, or as always, start by stating the profit function of the monopolists. And in order to find the market equilibrium, we state the profit maximization of the monopolist. So the monopolist will maximize their profits pi as a function of Q, and in this case it's defined in very general terms, just depending on these parameters, namely A minus Q minus C, all in brackets multiplied with quantity Q. Now we find this maximum again by stating or by checking the first order condition. So we are now calculating the first order derivative of the profit function and setting it equal to 0. If we now solve for the profit maximizing quantity Qm, we can find out that Qm equals A minus C all divided by 2, just as we saw it on the previous exercise. Now the price then results simply by plugging in this equilibrium quantity into the demand function, which is provided in this exercise, right? And by solving for Q. So what we have is A minus Q, so A minus C divided by 2, which then can be rearranged to equal A plus C all divided by 2. So now we know the equilibrium quantity and we know the equilibrium price of the monopolist in this very general terms. In task B, we are now asked to calculate the monopoly price and quantity for some specific values of these parameters. So for now, let's assume that A takes a value of 10 and C takes a value of 4. We are then asked to find the own price elasticity of demand at this point where Qm is the monopoly quantity. So we are again given a small hint to make the solution just a little easier. Namely, we are asked to note that the own price elasticity is defined as this function eta, a function of quantity and price, which is defined as minus the partial derivative of the quantity function with respect to parameter P for price multiplied with Q divided by P. That's just the definition of the own price elasticity. All right. Well then, first let's calculate price and quantity for these specific parameters that are given in the task. So if A takes a value of 10 and C takes a value of 4, then we can calculate that the monopolist's quantity equals 3 and the profit maximizing price of the monopolist equals 7. Now onto the own price elasticity of demand. Let's start with a quick reminder and try to remind ourselves of what the own price elasticity of demand actually means. It's easier to think about the interpretation of the own price elasticity, or it might be easier to think of this in discrete terms. So considering discrete changes in quantity or prices. If we are now in this discrete world, we can define the own price elasticity, so eta now with a little subscript d for discrete as a function of quantity and price. Again, we can now define this own price elasticity simply, of course, by rearranging the general definition which we were given in the task. We can see that the own price elasticity is defined as, now looking at the numerator, a relative change in quantity. So what we have here is a change in quantity, delta Q, divided by the level of quantity, which is conceptually nothing else but a relative change of quantity. And this all is divided by a change in price. And similarly to what we just had with quantities, this change in price is seen relative to the level of price. So the own price elasticity, of course, all of this with a negative sign, just by definition, the own price elasticity is conceptually a relative change in quantity relative to a relative change in price. Or, just to give a little more context, the own price elasticity of demand answers the question of how much does in relative terms, how much does the quantity change given a relative change in price? Or to put it maybe even simpler, what this does is to answer the question, given a change in price of, for example, 1%, right? So a relative change in price of, for example, 1%. What is the according relative change in quantity? So, given a change of price of 1%, how much percent does the quantity change? And of course the other way around. You can also think of it as, given a change in quantity of 1%, how much do prices change in percent, right? All right, going from the general to the very concrete example, just as a quick reminder on how to understand own price elasticities. Now, going back to the actual exercise, we were asked what is the own price elasticity of demand at these points Qm and Pm. So we know the demand function is 10 minus P, that was just given in this exercise, right? And we know the definition of the own price elasticity eta. We can now simply plug in all values that are needed in order to calculate this own price elasticity. Since we know the demand function, we can calculate the partial derivative of the demand function with respect to P, which turns out to be -1, right? Q of P derived by P equals -1 in our case. This is then multiplied with this fraction Q divided by P. And Q we already identified to be A minus C divided by 2, or specifically 10 minus 4 divided by 2. And all this whole fraction then is divided by P, which we identified to be 10 plus 4 divided by 2. So we plug in all of these numbers and find out that the own price elasticity in this particular scenario for this particular set of parameters comes out or turns out to be approximately 2.33, which is larger than 1. Now, why are we stressing that this expression is larger than 1? This comes back to the previous exercise where we were looking at a situation where we said, well, demand is elastic, which implies that a change in price results in an overproportional change in quantity. And that is exactly what we see in this scenario as well. Because this own price elasticity is larger than 1, we know that a change in price will result in an overproportional change in quantity. All right. Let's continue by talking about task C. A profit maximizing monopolist produces an output quantity Q at which the own price elasticity of demand takes a value of 0.8, so smaller than 1. Which of the following alternatives should the monopolist choose if they want to maximize their profits? And we are each time asked to explain our answer. Let's consider the first suggestion. The first suggestion is that the monopolist should increase their output quantity. Again, they want to maximize their profit, right? And we know that elasticity of demand is smaller than 1. Now, should the monopolist increase output quantity in this situation in order to maximize profits? The answer is he shouldn't, right? This proposition is wrong. Increasing the output quantity reduces profits in this scenario. The reason being that for this specific value of the own price elasticity, we know that the reduction in prices the monopolist will need to face for an increased demand quantity, the reduction in prices is smaller and outweighing. So we know that in this particular scenario, profits of the monopolist would actually decrease in case they increase output quantity. Now to the second proposition. A decrease in price. Would a decrease in price now be the solution for the monopolist if they wanted to maximize their profits? Now conceptually, of course, decreasing price and increasing quantity is exactly the same given a negatively sloped demand function. So, of course, this answer must be wrong as well. And the answer, the analytical answer to this question is exactly the same as it is for the first proposition. Simply because, again, in this monopolist's world with a downward sloping demand function or inverse demand function, doesn't matter in this case, the increase in output quantity is exactly the same or equivalent to a decrease in prices. Towards the third proposition, a decrease in output quantity. And now if we had this argument on an increase in output quantity, where we were seeing that this clearly does not increase profits but rather decrease profits, well then doing the opposite, of course, is exactly what the monopolist should do. So a reduction in output quantity would raise profits in this scenario. And again, the argument is exactly the same as it was under 1, just that in this case, the change in quantity, the sign of delta Q, would be the opposite. And then fourth and finally, choose an output quantity such that price equal marginal costs. Well, that, of course, can never be profit maximizing for a monopolist, because as we discussed in the previous video where we were talking about perfect competition, we know that price equal marginal costs implies 0 profits, at least in our simple world with constant marginal costs. But this deliberately choosing a price equal to marginal costs will not be the profit maximizing strategy of the monopolist. Right. So in this situation, the economic profits would be zero, and the monopolists would waste their market power, so to speak. All right, because just as a quick aside, what we see in the monopoly, in contrast to the perfect competition situation, is of course that the monopolist, in contrast to the firms in perfect competition, is able to actually have a positive price margin. So set a price that's larger, higher than marginal costs. All right. Then finally, an increase in investment in advertisements. Would that be profit maximizing for the monopolist? And well, in this situation, the answer really is unclear. The simple answer would be no, it doesn't have an effect. Well, why does it not have an effect? Simply because demand is in no way dependent on advertisement in this very simple model, right? In this very simple model, there is simply no room for advertisements. So using this very simple model, we cannot say anything about the effects of advertisements. Advertisements do not have any effects in the discussed model. However, we could, of course, come up with a more sophisticated and more complex model in which we can show that, for example, ads strengthen customer retention, which would be equivalent to lowering the own price elasticity of these consumers. Or we could alternative model an increase of demand for a given level of advertisements, etc. There's plenty of ways to include advertisement into models of these kinds. But the simple fact is, in this model that we were discussing right now, in this very first assignment, there is simply no advertisements considered. We will, however, have a look at more sophisticated models where you will learn how to think about these kind of parameters and how to include this kind of problems into these very simple baseline models.